So Friday, you guys learned about scatter plots and lines of best fits, and that's kind of just what we're going to briefly go over today. So here's your key vocabulary. A scatter plot is a graph used to plot data. It's used to determine whether if there is a relationship between two sets of data. For example, do y'all remember my example from Friday, like the temperature outside and snow cone cells? What do y'all think is going to happen if the temperature goes up to snow cone cells? They're probably going to sell more because people are hot and snow cones help them cool off. So you're going to see what's called a trend. Does that mean every day it's going to show the exact same thing?
No.
No. And if the temperature drops outside, what's usually going to happen? The snow cone cells are going to tend to go down, right? And so what we call that is a relationship, but there are those really weird exceptions. For example, let's say it's 40 degrees outside, but there's a field trip, and kids don't care if it's cold outside. They just see snow cones and they want it. So that's your weird exception. Right? So we say, is there a relationship? And we're not looking for it to be perfectly linear. We're looking for a linear trend. And so that's kind of what it looks like. So like right here, obviously it's not straight line, but it is showing a linear trend. All right. It can show possible trends in the data. So that's what you're looking for in scatter plots. Is this data even related? And if so, what kind of trend is it showing? All right, correlation is the relationship between paired data. So correlation can be positive, negative, or none. So if y'all don't want to write it, just write the signs. It can be positive, negative, or none. Do y'all see this is basically what we learned on Friday? Okay. So here's the correlation. Since this is going up, what kind of correlation would I call this?
Positive.
This would be called positive. The way that I would describe this is as x increases, y is increasing. Yes? As x is increasing, y is increasing. What is this called?
Negative.
As x is increasing, what's happening to y?
Y is decreasing.
Yes, but x is increasing,
Yeah.
y is decreasing. And this is called none. No correlation at all.
Nope.
This would be like if I wanted to know if there's a trend between your height and your grade.
That is scary.
It would look like this, right? Because tall people can have good grades and short people can have good grades. Tall people can have bad grades and short people can have bad grades. But what if I wanted to know if there's a relationship? So I would document all this stuff. I'd say, what's so-and-so's height? What's their grade? And I would go draw all these dots, and they would tell me, wow, there's no relationship, because it would look like that. Make sense? Yes or no? Okay, moving on. Down to the bottom, describe the correlation of the data. So what is this?
Positive.
Whoa, it's going. So this is
Negative.
negative. What's this one?
None.
None. What's this one?
Positive.
All right, easy. Same thing as Friday, yes? To find a line of best fit, use what you know. If you know the slope is positive, then obviously the slope would be positive, right? Look at the y-intercept. You can eliminate answer choices if it's multiple choice that you know are wrong. You can enter equations into y equals and you can check your graph, or you can make a table and use stat, which is what I taught you to do on Friday. So everybody look at this first example. This one says, which is the best equation of a line of fit for this scatter plot? Well, first of all, do y'all see a trend? What's happening? So what kind of slope is it going to have? So A and C would just be out because the slope appears to be negative. So we can eliminate A and C. Then it says estimate the y-intercept? Well, if I was to draw a trend, it's going to look something like that, right? It's kind of following that trend. Like here's the outside of the trend, and it's kind of in the middle of it. Y'all agree?
Yeah.
So what do you think the y-intercept would be around? What's the y-intercept of the trend going to be around? Thank you. Y-intercept is where it touches the y-axis. It's going to be up here at 8. So based off of that, I think the y-intercept's around 8. Well, guys, it's a trend line. It's called a line of best fit. Do all the dots fall on this straight line? But could you say they follow that pattern of that line? That's what a line of best fit is. Okay? So the answer would be which one? B. Why? Because the slope is negative and the y-intercept was around 8. Yes or no? Look at the next one. Which equation would most likely define the line of best fit? So draw a line of best fit. It's going to be something like, I don't know, that? Yes?
Yeah.
I mean, it's not perfect, but it's following that line. Are y'all with me? Is it going to have a positive or a negative slope? So what can I mark off? H and J, because the slope appears to be positive. It's going what?
Yeah, but on the answer it's negative.
Up.
That's why it says
All right, so what did we eliminate? H and J. Estimate the y-intercept. Is it above 0? Is it below? Well, I drew it above, but look at the only answers that are left. So it's probably got to be below. So to be really honest with you guys, I wouldn't feel comfortable picking that. I would say it's too close to tell. Because they have a negative 1/3 and negative 1, and I didn't even draw my trend line below 0, so I wouldn't like that. All right, so how would I pick my answer? I personally would go make a table of all those dots, and I would go put it in stat. And then I would pick the closest answer. So since I'm trying to hurry up, the answer would be F. Now this part, it says, if given a table of data, you can perform a linear regression using your calculator. So this is what would be new today. So how do you perform a linear regression? You enter your data into stat, and y'all already know how to do that, right? But then you would calculate the linear regression, and there's something that we have to turn on. I sure hope I remember. Go down. Do y'all see right above 0 in blue? It says catalog. So hit second 0, and this should pop up, and we need to turn on the diagnostics. So just scroll down. It's all in alphabetical order. So scroll down and turn on the diagnostics. Right there. See where it says diagnostic on? So you would hit enter and hit enter again. And it should say done so that it works. So I'll say it again for those of you that missed it. Hit second 0 to get to the catalog. Then scroll down to diagnostics on, hit enter, enter. Any questions? Okay, so it'll work now. All right, so how do you calculate the linear regression? Well, you're going to get your equation the same way I taught you from Friday. So everybody go to stat and put this table in. Remember the x's go in L1. Everybody get it in? Go to Stat Calc. What are we going to choose? Option 4, and hit enter, enter, enter. Do y'all see something new that popped up? The R, right? So basically, you don't really need that. Your A is your slope, your B is your y-intercept, okay? But the R is going to tell you if it's a good prediction or not. So the closer, like on these scatter plots over here, do y'all see how close these dots are kind of compacted together? That means that's a really good line of fit. Is this a great line of fit? Not really, because the dots are kind of really spread out, right? The calculator will give you an equation that will go with the line of best fit, but the R is going to tell you if it's a good prediction to use that equation. Like it's going to say, yes, you could really use that to make a prediction, and if it's good, this R is going to be really, really close to 1. So is this really, really close to 1?
Yeah.
Yes. If it's not a great prediction, the R would be like 0.7. Like, see what I'm saying? Like something a little less than 1. It's saying, hey, you can use this equation, but it's not perfect. Yes? Does that make sense? All right, so based off of this equation, where was I? Over here. I have y equals 0.3x, so I'm going to write that down, minus 0.8. Where did I get that from? Right here, yes? Does everybody see it? So based on this, which two answer choices could I mark out because this, what is this slope?
1/3.
That's about 1/3, yes? So can I mark off H and J? All right, and look at F and G. F is minus 10 and G is minus 1. What is this really close to? So the answer I would pick would be G. It's not always going to match perfectly, but you pick the answer that's the closest. And then it might ask, is the equation a good prediction? That's where you look at the R. If it's close to 1, you say, yes, it's a good prediction. If it's not close to 1, you say, no, it's not. All right, let's do this one. So go to Stat Edit, delete everything there, and enter in what you've done. Remember, don't ever put commas in, but if it's a decimal, it does have to be put in. Okay, question. What's the slope that it gave you? Negative 1,013, yes? What's the y-intercept it gave you? 10,854. And real quick question, look at the R. Don't look at the R2, look at the R. Is it really close to 1? Yes. Is it as close as the last one? So you see how it's a little bit less accurate, right? All right. So based off of this, can I mark A off? Okay. Could I mark B off? What was our slope? 1,013. Can I mark B off? Okay. Could I mark C off based on the slope? No. Right? And D has the same slope. Okay, so now we got to look at the y-intercepts. Which of these y-intercepts is closer to 10,800 D? All right, so now you're going to do your assignment. So if you look at the first page, this is all number 1. It all goes together. So what does the first part ask you to do? Take that table and get a slope, a y-intercept, and a line of best fit. So how am I going to do that? In stat. So everybody go do it. Okay, once you put it in, you go to Stat Calc, option 4. What's the slope? Let's round to the tens. 6.1. What's the y-intercept? 63.9. Can you write an equation now based on that? All right, what's the equation? 6.1x plus 63.9. Now, do y'all understand that that equation is not perfectly for those dots? It's for a line of best fit for those dots. Yes? All right. Now you can use that equation to make predictions. It says, once we've found our line of best fit, we can use that line to make predictions. Your turn. The X is the hours spent studying. The Y is the final exam grade. What do y'all think this trend is tending to do? The more time kids spend studying, their grades tend to be higher, right? Is it always going to work? Can you have a kid who studies really hard and still fails? Can you have a kid that's just naturally smart and didn't study at all and makes 100? So you're going to have those weird situations. But this is the line of best fit. Are we good? All right. So what is our line of best fit? We already wrote it, so we just rewrite it, yes? Y equals 6.1x plus 63.9. Now it says, predict the final exam grade for a student who studies 2.5 hours. So what would I do with this number? Plug it in for x. So I would do 6.1 times 2.5 plus 63.9, and I would just see what the answer is. And I'm just going to round to the whole number because grades are always usually whole numbers. Yes? Did everybody get 79? What if they studied for 6 hours? I'm going to plug in 6 for x, yes? Now, would I round up to 101 there? It's a grade, though, so I'm just going to say they made 100. Okay? Does that make sense? All right. Now here's the last part. If a student earned a 98, so are they talking about the X or the Y? The X is the hours studying, right? So they're talking about the Y right here. How many hours do you think they studied? So would I plug 98 in for Y or for X? So I would say 98 equals my equation. 6.1x, because that's the hours studying. I'm trying to find it. Plus 63.9. And I would simply solve the equation. Could you solve this in y equals? Yeah. Could you solve it by hand? Yeah, I'm going to solve it by hand. So I'm going to subtract 63.9. So 98 minus 63.9 is 34.1. How would I get rid of 6.1? How many hours do we think they spent studying? About 5.5, right? 5.5, 5.6. So about 5.5 hours. All right, so you're going to do the rest on your own.